Hello and welcome everybody in the last section or the last part of section 8.1 of AP Chemistry series. Today we're going to finish the first section of this unit. As we mentioned, if the concentration of OH is the same as the concentration of H3O+, then you have a neutral solution. In other words, like an example of that is water. Now, what will happen if you don't have amounts like the concentration of H3O+ is not the same as the concentration of OH? And how can I determine whether this is acidic or basic? So, for example, if I tell you, like as an example, the concentration of H3O plus is equal to, let's say, 1 times 10 to the power negative 4. Let's study the concentration of tomato, like here. Okay, my question is, how can I calculate the concentration of hydroxide in tomato? So the first thing that you have to do, suppose that the temperature is 25 degrees because it's not mentioned. We can say, okay, the Kw is equal to the concentration of H3O plus multiplied by the concentration of OH negative. And since the Kw has different values at different temperatures, if the temperature is not mentioned so far, we can consider the default value to be at 25 degrees Celsius, which is 1 times 10 to the power negative 14. The concentration of H3O plus is given to us and it's equal to 1 times 10 to the power negative 4, and it's multiplied by the concentration of OH negative, which is hydroxide, which is unknown. Then you have to divide that over like 1 times 10 to the power negative 4, this 1 times to the power negative 4, and then you cancel these guys in here and you'll end up with the concentration of hydroxide, which is equal to 1 times 10 to the power negative 10. Guys, let's just notice that some students fall in this mistake, which is they just divide the magnitude of this over this directly, and they got wrong answers. And this is the reason behind not using a bracket. So you have to use a bracket for the upper and for the lower fractions. I mean, like the denominator and the numerator. So just keep in mind to put them in brackets in order to have a correct answer. We have a concentration of hydroxide, and we have another concentration of H3O plus. My question, which of these is bigger than the other? We can just notice that the concentration of H3O plus is way greater than the concentration of OH negative. And at that point, I can tell you that the solution here is acidic because the H3O plus is greater than the OH. There's a beautiful figure that summarizes the whole thing. And if you look at this one here, if it's like the H3O plus is greater than the concentration of OH, then it's going to be acidic. And you know, like the acidic values have a pH values of less than 7. If they are equal, the pH is 7. On the other hand, if the OH is greater than the hydronium ion, then we can say that the pH is greater than 7, which means this is here is basic. The upper one here is acidic, and you can see this is a neutral for sure. And now, pause the video and read this question carefully and try it in your own and then see my answer. Now the question says, in a sample of lemon juice, this is the concentration of H positive, which is the same as the hydronium ion concentration. What is the pH? So first of all, we have to say, okay, the pH is equal to negative log the concentration of H3O plus, which is equal to 3.8 multiplied by 10 to the power negative 4. And if you apply that in your calculator, you will end up with 3.40. This is the pH. All right, let's read it again. A commonly available window cleaning solution has a concentration of hydroxide of 1.9 times 10 to the power negative 6. What is the pH? So first of all, we have two methods to reach to the solution. The first one, you can say, since the OH value is given to me, like since the concentration of hydroxide is given, I can say like the pOH is equal to negative log this answer, like 1.9 times 10 to the power negative 6. So if you apply it, the answer is going to be 5.72. All right, and there's a rule says if you add the summation of the pH plus the pOH at 25 degrees Celsius, the answer is going to be 14. And since the value here, which is the OH, is given, so we can say it's 5.72, and this is 14, and this is unknown for me. Then you have to subtract from 14, and then the pH is equal to a 0.28. Okay, so this is the pH. You can see it's greater than 7. It's basic, and that's why cleaning solutions always have a pH of a greater than 7. The second method, which is kind of um, like longer, maybe, actually, I don't know, you can use the value of Kw. We can say it's the OH negative multiplied by the concentration of H3O plus. You have the value of Kb, which is 10 to the power negative 14, and the OH is 1.9 times 10 to the power negative 6, and this is the concentration of H3O plus. And then you calculate the concentration of H3O plus, and then you take the negative log of the concentration, and you will end up with the pH. So both methods work, both are correct. Let's go to the last questions. Pause the video and read the question carefully before you see my answer. The question says, the average pH of normal arterial blood is 7.4. At normal body temperature, which is 37, the Kw is this. Calculate the concentration of H positive, the concentration of OH, and the POH. I need to calculate the concentration of H positive, which is the same as the concentration of H3O plus, and it equals to 10 to the power negative pH. 10 to the power, what's the pH mentioned? It's 7.4. It's 7.4. And if you just raise it to this power in your calculator, you will end up with a number of 3.98 times 10 to the power negative 8. All right, so we calculated the first part today. And the second part is asking me to calculate the concentration of OH is calculated from the value of Kw. And you can see that the Kw is not the same as like at 25 degrees. It's greater because the temperature here is higher than 25. So you have to say Kw is equal to the concentration of hydroxide multiplied by the concentration of H3O plus, and it's equal to 2.4 times 10 to the power negative 14. And here the OH, which is the unknown, and the concentration of H3O plus is equal to 3.98 multiplied by 10 to the power negative 8. And if you do some algebra, the point, you divide it over the same number in here, and the same thing here, 3.89 times 10 to the power negative 8. Concentration of OH is equal to 6.03 times 10 to the power negative 7. Okay. And if I need to calculate the pOH, and it's equal to negative log the concentration of OH, which is 6.02 times 10 to the power negative 7, and you will end up with an answer of 6.22.